Hello again, Year 10. This is our fifth lesson on bearings, and today we are going to continue the work we started last lesson by looking at how we can use trigonometry in a bearings type question. The main difference between what we will be doing today as opposed to last lesson is last lesson we were calculating the bearings when we were given some distances. Today we are going to have the bearings given to us in the question and we are going to work out some distances between objects. So once again, we're going to look at two examples. And again, the key to these questions today is a good, tidy diagram. Get the diagram right, you're more likely to then have a little bit of understanding as to what you need to do next. So, example 1 says an aeroplane flies 50 miles on a bearing of 112. How far due east has it travelled to the nearest one decimal place? So let's start with our aeroplane. If you're ever unsure, I would suggest you put a blob in the middle of the page because then you can pretty much go off in any direction you want. But 112 degrees is going to be a little bit further around than east. So I, for example, know if my north line is straight up, then east 90 degrees is in that direction. So 112, I'm not measuring it out, I'm just approximating, is that. And that line is going to represent my 50 miles. So that's where the plane started. That is where it currently is. And the angle that I currently know is this one here, 112. Now this question says, how far east has the plane gone? So what it is asking us to do is break that distance into an east component. There is also a south component, because you could think of this 50 miles as going so far east and then so far south. And it's asking us how far east it is. So it wants this distance represented by my dotted line. I will call that E for east. So I've got a right angled triangle. I've got 50 miles, but the 112 isn't part of the angle in the triangle. So what I need to figure out is what this angle here is. Well, if it's 90 degrees around to east, how many more degrees from 90? That is 22 degrees. Now, one little strategy, and you'll probably see me do this later on, or in my example, in my working out yesterday, is if things get a little bit messy on a diagram, I sometimes do a really quick sketch of a diagram just to get a little bit more simply what's going on. Sometimes all of this information can be a little bit confusing, so another diagram quickly drawn out can really help. So, what do we know? Well, this side here is opposite. The 50 degrees opposite the right angle must be the hypotenuse. And the E is my adjacent. So which rule am I using? Well, I know the hypotenuse. I'm trying to find the adjacent. The only trigonometric ratio that works for those is cosine. Cosine theta is adjacent over hypotenuse. So let's pop in what I know. Cosine of 22 equals adjacent E over hypotenuse 50. This is a nice one to rearrange. The divide by 50 becomes a multiply by 50. So E is 50 lots of cosine of 22. The question asks for one decimal place. Do make sure your calculator is in degrees. And I've managed to get that as 46.4. It's 46.35, and that 5 will make it round up to 0.4. Let's put some units on the end. It is miles. Let's look at our second example. This time it says ground troops are on a bearing of 72 degrees from their base. So I know that north, straight up, 72, well, east is 90, 72 might be a line something like that. I'll put the other north line in. Don't know if I'm going to need it yet. It says ground troops are on a bearing of 72 degrees from their base. So let's get this the right way round. From their base. This must be the base, and this is where the ground troops must be. It says they know they are a distance 6 kilometers due east from their base. Well, there's that 6 kilometers. But don't know their distance due north. That is that measurement there. It says work out the shortest distance between the base and the ground troops. So we're working out this distance here. So the way that I would do this is I would look for this angle that we need in our triangle. We know that all of this must be 90 degrees, so this is 18. And once again, I'll just do a quick little more simple sketch of what I've got. 18, x, and 6 kilometers. So let's populate what we know and see if we can figure out which trigonometric ratio we need. This is opposite. This is hypotenuse. This is adjacent. It is another cosine question. So let's set this up. Cosine theta is adjacent over hypotenuse. So cos of 18 is 6 over x. Well, this is a slightly more awkward one to rearrange because the unknown is on the bottom. So let's rectify that by multiplying both sides by x. So x cosine 18 is 6. And then I can get the x by itself by dividing by cosine. So I know that x is 6 divided by cosine 18. I'll type that into my calculator. 6 divided by cosine of 18 is 6.3 kilometers. And that is 1 decimal place. So there are 4 questions for you to try. And you can access a better version of these questions by going back to my instructions. I also have done a few extra diagrams for questions 2, 3, and 4, just in case you're struggling a little bit. So, for example, you try question 2, you're not sure how to proceed. If you look at my diagram, that might just give you a little bit more of a starting point if you are struggling. Of course, if you are doing fine, then just go for it. Once you've finished the questions, all of the answers are provided on my PowerPoint, so do have a look, do mark those questions, and do get in touch via the Ask the Teacher channel if you are having any problems.